to put that cosine of x equal to 1, then divide by 2. And then x itself is equal to cosine to the minus 1 of 1 over 2. Okay, that's what we talked about just before things went overboard. All right, so the question is, what angle gives us this a half? So here's my triangle, right, which is 2, 1, square root of 3. This angle down here is my pi over 3. This angle up here is my pi over 6. So the question is, which angle for cosine gives us a half? Well, it's this angle right here, the pi over 3, if you think about it, because the cosine of pi over 3 is adjacent over hypotenuse. So my x value, and the way I teach this is I don't call it x, I call it x prime, and I'll explain why I do that in a minute. X prime is how far am I from the x-axis, and then I'm going to decide what quadrant I need to put that deviation in. So I just decided that was pi over 3 as my deviation, because the cosine of pi over 3 is the 1 over 2. So in other words, I'm not asking for the cosine of pi over 3. I'm asking what angle gives me 1 over 2 for cosine. And the answer for that, of course, is pi over 3. Okay, so let's make sure everybody's okay with that. Now, you can use your calculator to do that, right? If you go to your calculator and hit that shift button or that second function button, make sure it's in radians, right? And you can try this on your calculator right now. And you put the 0.5 in. Depending on the calculator you have, and make sure it's in radians, you should get that pi over 3 value. Now, pi over 3 may not show up on your calculator as pi divided by 3. It might show up as some decimal, right? So you have to be able to figure out what that is. Can we do it again? Okay, sure. And I see a hand going up as well. Yes, Quinn, please go ahead. Good, good. So you're asking, so I have to repeat your question. So can I explain to you what the last term is actually telling us? Yes, I can. So maybe I shouldn't focus so much on you getting the pi over 3, although it's important that you know how to do that. What I'm saying is this, right? Try to figure out which angle gives you a half for cosine. That's the most important thing. Now, I can share my calculator with you to show you how my calculator does it, but then it kind of is more important how your calculator does it. And I'm also trying to remind you that you need to be in radians for this to work, right? So make sure you're in radians. So I'd like everybody to try this right now. Let's just make sure that we're all on the same page. Get your calculator out, right? Everybody should have their calculator close by. Look for that shift key or that second function key, or I don't know what it is on your calculator. Where we are now. Let me go back and try to answer the question that I got from Quinn a few minutes ago. What does this pi over 3 actually mean? What does it mean? Well, it means it's the thing that you get from your calculator when you hit the cosine to the minus 1 and hit a half, okay? Now, here's the way I like to teach this. That is not my answer yet. The question is, and I'm going to draw a little, well, I don't know why it's doing this. I'm going to draw a little Cartesian plane, and I'm going to ask the question of, since I want my cosine to be a positive a half, and Quinn, I'm going to ask you this question. Help me out here. What quadrants should I be putting my angle in that I need? I need an angle that's in a positive quadrant for cosine. Can you pick the two, and there are two of them. Can you pick the two quadrants that need to have that in? 1 and 4. Thank you very much. So here's what I'm going to do, Quinn. Not just for Quinn, but for everybody else. I'm going to go ahead and put in that pi over 3 answer that I just got in both of those quadrants as a distance from the x-axis, always from the x-axis. So that's going to be pi over 3 in quadrant 1 and pi over 3 in quadrant 4. He's absolutely right about the right of the quadrants. I need 1 in quadrant 1. I need 1 in quadrant 4. Okay, so here's the next question. what are those actual angles? Because those are the angles as measured from the x-axis going up and going down into the fourth quadrant. But what angles do they actually represent? Well, I'll give you one of them, and let's see if we can get the other one. One of those answers is actually pi over 3, right? Because if I'm measuring from standard position, so I'm starting off right here, and I'm going around in this direction, counterclockwise, then I am pi over 3 away from my starting position. But how about the fourth quadrant angle? So to get that fourth quadrant angle, I'm going to have to go all the way around to here to get to that fourth quadrant angle. Now, can you help me to figure out what that angle actually is? Starting from 0, right? If I start at 0 and I go through the first, through the second, through the third, I end up somewhere in the fourth quadrant, I'm pi over 3 away from a full cycle. Can anybody suggest what that second angle is that I need to get for this answer? Anybody, not Quinn in particular, but anybody. I need a fourth quadrant angle. How would I get a fourth quadrant angle? All right, so let me say again. I'm starting at the 0. I'm going way past pi over 2. I'm going way past pi. I'm going way past 3 pi over 2. And I'm not going to get all the way back up to 2 pi because I'm pi over 3 short of that. So look at what Hussein just said. He's absolutely right. It's 2 pi minus pi over 3. So my second angle is going to be to take the 2 pi and minus pi over 3 from that. So what does that actually mean? My second answer, and I'm going to tell you what that is, and Brandon has already jumped the gun, and so has Quinn, and so has Chrisania, all of them doing a brilliant job, 5 pi over 3. So those are my two answers, right? And how do I know where to put those answers? Go back to what Quinn answered a few minutes ago. I need to know where cosine is positive. Why? Because when I asked for the cosine to the minus one, it was of a positive a half. If that had been a negative a half, I'd be asking for a different quadrant. No, I'm going to leave for now answering the same question if I was going from minus pi to pi. I'm going to leave that for now. If we have some time at the end, we'll come back and look at that as well. All right, let's run to my second question. How about this one? And I already have my quadrant set up over here. All right, but let's see if we can answer this question. 2 sine squared x is equal to 1. Okay, so let's bring this down. And we're going to go through some of the same steps we just did, which is to first of all, divide both sides by 2. So that hopefully makes sense. We're going to take sine, oh, sorry. We're going to take my sine squared x and set that equal to 1 over 2. All right. Okay. So what's next? Think about what sine squared means. What does it mean to be sine squared? Sine squared means you square. So Hussein is right. Square root the two sides. So my sine of x, when I square root it, is equal to the square root of 1 over 2, which is equal to the square root of 1 over the square root of 2, which is equal to 1 over root 2. Okay? So I square root two sides. But there's something I'm missing from this. I should have said from the very beginning, plus and minus, plus and minus, plus and minus, plus and minus. Now, I'm going to be asking, so the sine of x, let me just write this down now. The sine of x is equal to the plus and minus. Oh, I don't need that thing at the top anymore. Let's get rid of that. Plus and minus 1 over root 2. So now our thing is now to ask, which angle is that? And I'm going to ask you to focus on the plus square root for now. We'll get to what happens when it's negative in a minute. By the way, there is already a video for solving trig equations, which I did a couple of years ago on YouTube. But of course, I'm creating one now, so you may want to focus on the one I'm doing now. But I have one already, which goes through a lot of these same examples, which I did a couple of years ago. But let me get back to this. So the question is, when I take x being equal to sine to the minus 1, it's now sine to the minus 1 of 1 over root 2. That's what we're asking for. Does anybody know what that is? And you can use your calculator. And depending on your calculator, how sophisticated it is, it will give you an exact answer. It will give you a decimal. Or if you have your, and pi over 4 is right. And if you have your triangles nearby, then you could actually figure this out for yourself. It is pi over 4. But I'm going to call it x prime again. I always call it x prime because now I'm going to say, where do I put that pi over 4? What quadrants should I put that in? Should it be quadrant 1, 2, 3, or 4? When I asked the question the last time, I got an answer that it was 1 and 4 because it was cosine and it was where cosine was positive. So we're asking for sine. But the other thing is we're asking for where sine is both positive and negative. So what quadrant should I be looking in that case? Does anybody have an answer for that? Which quadrants make sense? Brannon is 100% right, all of them. They're actually all four. Good. Davina and Brannon, both. I have to acknowledge Davina as well, who was even a little bit ahead of Brannon. All four quadrants. So here's what I'm going to do again. I'm going to put that pi over 4 as a deviation from the x-axis. That's how I like to put it. So I'm going to call it a pi over 4 here, a pi over 4 here. Again, always measuring from the x-axis. A pi over 4 here, and a pi over 4 here. All four quadrants need answers. So let's start with the first quadrant. So I'm now ready to write the actual values of x. I meant to write it in black. The actual values of x. Well, I'll start you off with the first one. The first one is actually pi over 4 because that's in the first quadrant. That's how far I am from the x-axis. But how about in the second quadrant, right? I am somewhere in the second quadrant, quadrant 2, right, over here. This is quadrant 3, this is quadrant 4. I'm somewhere over here. I've gone past pi over 2, but I haven't yet quite made it to pi. So what is this angle right here? And anybody help me with that? How would I get that angle exactly? So pi minus pi over 4. Thank you, Kelvin. Well done. So my second one is going to be pi minus pi over 4. And then we'll actually calculate that a little bit later on. How do we get the third quadrant? Not Kelvin this time. How do we get the third quadrant? So I've gone past half a pi. I've gone past pi. And I'm now pi over 4 away in quadrant 3. Can somebody help me out with how I would get, thank you, Hussein, pi plus pi over 4? Now I need to get into, Kelvin and Hussein, hold your fire now. Let's go into quadrant 4 now. So I've gone past half. I've gone past 1. I've even gone past 1.5, but I'm not quite yet at 2 pi. I'm pi over 4 short. And Brannon is right. 2 pi minus pi over 4. So what do these all translate to? Well, let's translate them into English. This is pi over 4. How about the second one? What's pi minus pi over 4? Anybody? If I took pi and minus pi over 4 from it, what would that be? There. Thank you, Chrisania. 3 pi over 4. The third one, third quadrant. Pi plus pi over 4. Thank you, Alexander. 5 pi over 4. And then in the fourth quadrant, 2 pi minus pi over 4. What is that equal to? 2 pi minus 7 pi over 4. You guys are good. Okay, thank you, Donna. Well done. Thank you, Chrisania. Well done. Those are your answers. Those are your 4 answers right there. Right? So what values of x? Again, I only want answers between 0 and 2 pi. I could ask the same question from minus pi to pi, and if we have sometimes a little bit more work there, some of the answers are the same, but not all the answers are the same. A little bit more work here, but It's the same approach. It's the same approach. Okay, now let's get to this. Uh-oh. 4 sine squared theta, or x, minus 3. All right, let's go through the process that we always go through for solving an equation. Let's bring that 3 over. So 4 sine squared x is equal to 3. I just simply added the 3 to the other side. Then I'm going to divide both sides by 4. So sine squared x is equal to 3 over 4. And then we know what happened the last time. Why did we ignore the negative when taking the sine inverse of 1? We did not. Okay, Hussein, thank you for that question. So I'll just read that question out. Why did we ignore the negative when taking the sine inverse of the 1 over square root of 2? I'll go back and look at that again. We did not. We said that we're going to take the positive and negative when we took the sine to the minus 1, right? So because of that, and let me tell you this, my approach to this, Hussein, is to always only look at the positive answer, but then you try to figure out what quadrant it goes in by looking at the actual sign. So because it's plus and minus, that is why we went to all 4 quadrants. Remember, Hussein, when I asked what quadrants to look at, and people were saying it was all 4 quadrants? That's why they were saying that, because we're looking at both positive and negative answers. Okay? All right. Thank you very much for asking. I appreciate those questions. All pass, Alexander says. Okay, Alexander. All right. So let's get back to this. Sine squared x is equal to 3 over 4. And of course, the last time we took a square root, so we'll do that again. So the sine of x is equal to the square root of 3 over 4, which is equal to the square root of 3 over the square root of 4. These are all both plus and minus, by the way. Both plus and minus. Which is equal to root 3 over 2, plus and minus. Okay? That's one of the special angle results. So sine of x is equal to plus and minus root 3 over 2. So x itself is equal to sine to the minus 1 of root 3 over 2, but plus and minus. All right, so let's give the calculators a little work now. All right, you all have your calculators there, hopefully. I'm not going to put my calculator up on the screen. I'm just going to ask you to use your own calculator. What angle are we talking about? And again, I'm going to call it x prime for now. Not actually x, but x prime. Crisania says pi over 3. Do we all agree with pi over 3? With what Crisania just says? Donna says yes. And Davina says yes. So when we got 2 people on your side, we're going to go with it, Crisania. We're going to go with pi over 3. So now let's draw our grid. And we need a pi over 3, but we need to ask what quadrants to look for it in. Right? Crisania and Brannan, and I'm sure some other people are going to jump in and say, yes, all 4 quadrants. The same as the last time. So I'm going to go ahead and I usually use a red line. So let me be consistent with that. I'm going to put in a pi over 3 in all 4 quadrants. Now remember, I'm always starting from 0, and I'm going in a counterclockwise direction. All right? So the first answer that I will actually have, this is x prime, which is the pi over 3. The first answer that I would expect to have would be that x itself is equal to pi over 3. That's the one in the first quadrant. All right? And why all 4 again? Okay, Donna, that's a great question. And I see that people have jumped in and answered that question. Okay, so looks like I'm good then. So the question was, why is it all 4? And the answer was because of the plus and minus. If it wasn't the plus and the minus, then we'd have to ask, is it supposed to be plus? In which case, we go to the quadrants that sign is positive. It's supposed to be minus. We go to the quadrants that sign is negative. But I appreciate the question. All right, so let's get the next angle in the second quadrant. So we start at 0. We're going to go past half a pi. We're not going to quite get to pi because we're short pi over 3. So we're saying is right. So it's pi minus pi over 3. And by the way, you always stop me if this isn't making any sense. We'll figure it out later on, Alexander. I see that you have jumped ahead. How about the third quadrant angle? So I've gone past pi, and I'm another pi over 3 into that. So pi plus pi over 3. And then my fourth quadrant angle now, right? I've gone all the way around past half, past 1, past 1.5. I didn't quite make it to 2 pi, so 2 pi minus pi over 3. Great. 2 pi minus pi over 3. Now let's translate to figure these angles. We look at the y-axis. No, we always measure from the x-axis. Always from the x-axis, okay? So all of these pi over 3s that we're looking at right now, Davina, right, are the angle between the x-axis and where that line is. That's where the pi over 3 is. Are there exceptions? Only with the cofunctions. Only when we have cofunctions do we talk about deviating from the y-axis. So remember when we're doing those things about pi over 2 plus pi over 2 minus 3 pi over 2, 3 pi over 2 minus, that's when you look at the measurements from the y-axis. But all the time you look at that's the only exception for cofunctions, okay, when you're trying to switch from sine to cosine. Does that make sense, Brendan? Okay, great. All right, so let's finish this up by answering all of these. Well, the first one is just simply pi over 3, so we're good there. And somebody already put for this one that this was, well, 2 pi over 3. I forget who it was. Let's get to the others, though. Pi plus pi over 3. Look at that. Alexander has everything all laid out there for us. Wow. Okay, Alex is asking, Christian is asking Alex what now? What's, okay, let me put those answers in. By the way, Alexander's answers are good, so I'm going to go ahead and put those in. So pi plus pi over 3 is a 4 pi over 3. And the 2 pi minus pi over 3 is the 5 pi over 3. Is everybody comfortable with those answers? All right. I just want to make sure that we're all good here. Let me check in with a couple of, okay, good. We're checking with a few people who haven't said very much. So let me see. How about Jenna? Jenna, how about you? Are you good with that answer? Jenna, where's Jenna? Where is Jenna? There you go. Okay, so you're good. All right, good. Okay, so far so good. I'm liking the questions I'm getting, and I'm hoping that people are understanding what we're doing. Let's get to this one. Things just changed a bit. Any thoughts on how we might be able to solve this? 2 sine squared x minus sine of x. Let me drink some water here while you think about that. How would we solve this kind of equation? All right. Remember, we're trying to isolate the x. That's your goal. But how do we get there? Well, I'll give you a, let's see what we got here. Factor out the sign. Do we use a trig identity? Factor out the sign. Okay, I see what's in Duja, Brendan. Okay, some interesting ideas. The one I'm going to go with is factoring. All right, that's the one we're going to go with. So we're going to factor out the common factor between both of these, which of course is the sine of x. And let's see what we're left with. We're left with the 2 sine x minus 1. Okay, is anybody comfortable with that way of factoring it? Do we use a trig identity? If we had a trig identity, Hussein, that we could use, sometimes that is the way to go, by the way. But in this case, I don't see that that's going to help us out. One of the things that you're going to try to do when you're solving these equations is to try to work with only one trig ratio. So if you have sine and cosine in there, try to change the sine to a cosine so it's all sine or it's all cosine. In this case, it was all sine. So I wouldn't use a trig identity here, right? Because the only trig identity I know for sine squared brings in cots, and I don't really want to do that. How do we have 2 sine x left over, you're saying? Oh, all right. So let me bring this down a bit. Remember how to factor? The common factor here is sine x, Ryan. So I'm going to take this and divide it by sine x, and this divided by sine x. Okay? So let's take the sine x and divide it into the first one. What do you have left, Ryan, when you divide 2 sine squared x by sine x? What's left? You tell me. Right? 2 sine squared x, which is sine x times sine x. So 2 sine x, which is what we got. And when I divide sine x by sine x, what do I get for the second one? 1 or minus 1 is correct. Yes, perfect. Perfect. Now, the reason that this is useful, let me bring this back up to where it was. And thank you for the question, by the way, Ryan. The reason that this is useful is because we can now talk about what we've been using for the past couple of weeks, which is the zero product law. Zero product law, if you remember, says that when I multiply two things and get zero, one of those things has to be zero. So we really have two equations that we have to solve, right? One of them is the sine of x equals 0. And the other one is 2 sine x minus 1 equals 0. We have to solve both of those equations. So we have quite a few solutions here. Where is the sine of x 0 is the first question. So let me give us some room here. Where is the sine of x 0? Let me remind you about something, right? Sine is my y value. Think about that circle that we started off looking at our trig functions with. And you had it was that vector was 1 unit long. It started off at 1, 0, then it went to 0 minus 1, then it went to minus 1, 0, then it went down to 0 minus 1 at the bottom, then it went back up to 1, 1, 0. So there were two places where the y value was 0, right? Can anybody tell me where those two places were? There were two spots as we were going in that circle, right? Looking at the y value, because sine is my y value. There were two places where two angles that gave me 0 for y. Let me draw it here. Let me draw a quick thing right here. Oh, sorry. Right? So we have that circle, then we have that line that's 1 unit long, right? And it starts off at 1, 0. Then it's going to come up here, and it's going to be 0, 1. It's going to come over here, and it's going to be minus 1, 0. It's going to come down here, and in which case it's going to be 0, minus 1. So I see that people finally remember now 0 radians and pi radians and 2 pi radians. So those are 3 answers. The answers need to come between 0 and 2 pi. So they're really 3 answers. So Roma and Davina, if you put your answers together, then you're both right. Right? So here's my x value. And it's not going to be x prime this time because it's the actual value of x. Let me go back to black. It's the actual value of x. It would be 0. That's one of the places that the y value is 0. It would be pi. It would also be 2 pi. Remember, the way the question is written, it says from 0 to 2 pi, including 0 and including 2 pi. So because of the square brackets, all of those answers would be included. So Davina, can you see why we also have to put 0 into the answer? And Kelvin, do you also see why it's also 0 as well? Right? 0 is one of those places where you also have to include it. So I have 3 answers so far. Right? If this question had said between 0 and 2 pi, but not including the 0. Yes, Quinn. Go ahead, please. Sure, sure. And what is the y value there? Sine is your y. Yes, sine is your y. Okay. So it's the same as 0 itself. So remember, 0 and 2 pi are actually at the same place, right? they're what is that word that they use again? Coterminal. They're coterminal angles. So they're both in the same place. So if 0 is an answer, then 2 pi is an answer. As long as your domain extends between those two. You're confused. Can I do it again? Sure, I could, Sherbon. Absolutely. So remember this, Sherbon. Remember this circle that I drew that went, this grid that I drew, which was 1 unit long. And when it stopped on the x or the y axis, it carved out these points, the 1, 0, the 0, 1, the minus 1, 0, and the 0, minus 1. Do you remember that, Sherbon? Do you remember that from when we first started looking at this? Okay. So this angle right here at the start where the 1, 0 is, consider that to be 0. So I'm going to put 0 here. Consider this to be pi over 2. Consider this to be pi. Consider this to be 3 pi over 2. And consider this to be 0 or 2 pi. They're both the same. Okay? So the question now is, where do I stop in my circle to get my y value to be 0? Is the question, Sherbon, right? Where do I stop? Where do I go? Well, the first place I'm going to be stopping at is 0, right at the start, because my y value there is 0. Does that make sense, Sherbon? Yes? Okay. Where else do I go? Look for the y value to be 0. How far do I have to go for my y value to come back to 0 again? Where's the next spot that happens? Where's the next place? Look at the y. Just focus on the y's for now. Right? How far do I have to go for that y value to be 0? Are you understanding my question? If you're not, then pi. There you go. And where else can I go again? There's one more spot within one revolution that I can get a y value of 0. Right back at 2 pi. So that's where those three answers came from: 0, the pi, and the 2 pi. Are we good now, Sherbon? Does that make sense? Okay, good. Perfect. So that's 3 answers so far. Let's get to the other side. Well, we've done this before, 2 sine x minus 1. So let's just say then that 2 sine x is equal to 1, and then sine of x is equal to a half. So x is now equal, I'm going to call it, so x is equal to sine to the minus 1 of a half. So I'm going to call it my x prime, because x prime is going to tell us what quadrants to get to, right? But let's just first of all find what angle is a half for sine, right? And I believe, if I'm not mistaken, that it's pi over 6, but you all should check that because I need my triangles to help me out with that. Okay, a lot of you are agreeing with me on that. Thank you very much, Alexa, Davina, and Crisania. Okay, great. So pi over 6. So the next question now is, where is my pi over 6? What quadrant should I put that pi over 6 in? I'm going to use my red line again, right? Quadrants 1 and 2. Thank you, Brandon. Thank you, Davina. So here is my angle, pi over 6 away in both quadrants 1 and 2. And why is it in quadrants 1 and 2? Because it's sine. And the question is, where is sine? Positive, not negative. We're not talking set negative and positive, just where it's positive. And that's in quadrants 1 and 2, just exactly what Brandon and Davina and Crisania said. So now the question is, what is the actual value of x? Right? What is x actually equal to? Right? What we're talking about is x prime. But what I want to know is, what is x? Well, the first answer in the first quadrant is pi over 6. That's good. But how do I get my second quadrant angle? Can anybody help me with that? The angle in the second quadrant, which is pi over 6 away, so good. So pi minus pi over 6. Okay. So here are my answers then. 5 pi over 6. So my final answer, a little box here, my final answer is a combination of both of these answers. Now, some teachers will say it has to be in order of magnitude. Mr. Kamok says, just make sure you got them all. I don't really care what order they're in. So because I said that, I'm going to put them in just the order that they are right now. There's 0, there's pi, there's 2 pi, there is pi over 6, and there's 5 pi over 6. Right? All 5 of these answers will work. All right? What is the order of magnitude? Order of size. So if it was in order of size, the smallest angle would be 0. And let's see, the next one would be pi over 6, and then 5 pi over 6, and then pi, then 2 pi. I don't really care, right? Just give me them all. That's what's most important to me. How do we get the pi over 6 again? Okay, Ryan, thanks for the question. Go to your calculator. Depends on your calculator. Look up the sign to the minus 1 of 1 over 2. So using the second function key, if you like, or shift or whatever it is on your calculator, use the inverse function on your calculator to find what that is for a half. Okay, can you try that for me, please, Ryan? See what you get? Now, your calculator may or may not give you the actual pi divided by 6, or might give you a decimal. I don't know how your calculator is going to do it. Getting a decimal, that's because maybe your calculator doesn't have that capability of showing it to you as a fraction, but then you can always go back to the triangles, right? So Shiobon and Brian, go back to the triangles. Let me show you again what I mean by going back to the triangles. Here is my triangle for there's pi over 3 here, and there's pi over 6 here, right? This is the root of 3. This is 1, this is 2. So which of these gives me, remember, what we're trying to get is a half for sine. How can I get a half for sine? Well, if I were to use a pi over 3, it wouldn't be a half because for sine it's opposite over hypotenuse, so that wouldn't work. If I use pi over 6, it would be opposite over hypotenuse, which is in fact a half. So that's one way to look at it. All right, Shiobon. I'm not going to force you to go and get a calculator that is necessarily going to give you the answer as pi over 6, but that's the alternative to that. Okay. All right. Let's see now. Let's see if we can get a few more in before the class is done. Whoa. 3 cos squared x plus 7 cos x plus 2. Can this be another thing that we have to factor? And the answer to that question is yes. I'm not going to keep you in suspense on that one. We have to factor it. Now, you might find it easier to convert this into a regular quadratic. So why don't I do that? Why don't I say that let's let, I don't know, p equal the cosine of x. In which case this becomes 3p squared plus 7p plus 2. Is it necessary to do that? Not really. I mean, if you're comfortable factoring it without the substitution, by all means do it. By all means do it, right? But for some of us, putting it into a substitution model kind of makes sense. Now, I hope that people are at the point where they don't need me to teach them how to factor a quadratic. Even if it's a quadratic, it's a little bit more work, which is like this one. Does anybody know what the factors of this quadratic are? So I'm seeing x equals 2. Oh, what are the factors? Give me the factors. Before we get to what x is equal to, just give me the factors first of all. Something with a p here, something with a p here. Come on, give me the factors. So x plus 2 is 1, somebody is saying. Actually, it's actually p. Let me go back and be consistent here. It is actually p. So p plus 2 and 1, what's in the other bracket? 3x plus 1? We'll test that out. 3p plus 1. So 3 times that, that's 6 plus 1 is 7. I believe you're right. I believe you're absolutely right. Okay. So Divina is good, but how is everybody else on that? Right? Everybody else can factor. Let me check in with the room again as usual. All right. How about you, Lance? Does that all make sense? Where Lance is? Where's Lance? Okay. So I'm just going to go back, put it into cosine form. So it's going to be 3 cosine of x plus 1 and cosine of x plus 2 equals 0. And we know that we can actually use that zero product law and create two separate equations. 3 cosine x plus 1 equals 0, and cosine of x plus 2 equals 0. All right, we've done enough quadratic functions and zero product law functions for us to know how that works. Let's keep going. So therefore, 3 cosine x equals minus 1, and therefore the cosine of x is equal to minus 1 over 3. Now, we know that for us to get rid of the cosine, we have to take the inverse function. So x equals the cosine to the minus 1. Now, here is the way I teach it. I'm not saying that you have to interpret it the way I'm about to do it. I never, ever put cosine to the minus 1 with a negative into the bracket, because sometimes I don't know what that calculator is trying to tell me. So I'm gonna urge you, I'm gonna suggest to you, and you don't have to take my suggestion. If you have another way of doing this, if you have another way of getting to the Pickering Town Center and it works every time, by all means, you take your own path. But here's what I do. I still call it x prime, but I say cosine to the minus 1 of positive 1/3. I'll explain why I do that in a minute. All right? I don't put cosine to the minus 1 and ask the calculator to tell me what cosine to the minus 1 of minus 1/3 is. I ask it to tell me what cosine to the minus 1 of 1/3 is. Then the calculator is going to give me an answer. Actually, let me put this under here. And let me erase this. So, you got the SMAE. Sorry about the top part. I'm not sure. You guys kind of left me behind here. Let me go back and see what's going on. All right, got the SMA. What is an? You got the same. Oh, okay, just a misspelling. All right. So here's what I want you to do now. Go to your. This is not going to be one of those special angles. So you can't use one of those triangles to get it. Go to your calculator and ask your calculator to give you the cosine to the minus 1 of 1/3. Not of minus 1/3. Let me stress that. Ask your calculator to give you the cosine to the minus 1 of positive 1/3. I'm doing the same thing on my calculator right now. And I'd like to hear what you're getting on your calculator. You got a decimal. Of course, you're going to get a decimal. It's not a special angle, right? This is not one like 1 over root 2 or root 3 over 2. This is 1 over 3. There's no special angle for that. So a bunch of people are saying 1.23. Good. So I'm going to put that in. Let me move this down a little bit here. All right. So I'm going to say that x prime is equal to 1.23. And by the way, is everybody getting that? Do you put a negative sign beside it? No, I don't. I do not. I do not. I'll explain to you now what I'm saying right now why I don't. I want to make sure everybody's getting this on your calculator though, right? So let me check in with Natasha. Natasha, are you okay with that, getting that positive 1.23 there? Natasha, do you get that on your calculator? Perfect. Okay. So here's where the negative comes in for me. This is the come out style way, right? I say, okay, I ask the calculator for cosine to the minus 1 of 1/3, but originally this was where the cosine was negative. So this 1.23 needs to go where cosine is negative. That's why I look at it. So can you now tell me, anybody, which quadrant should I be putting this angle of 1.23 in? Quinn says quadrants 2 and 3, and I absolutely agree. So I'm going to put in quadrants 2 and 3, this 1.23 angle right now. Why is he saying quadrants 2 and 3? Because that's where cosine is negative, right? Cosine is positive in quadrant 1 and positive in quadrant 4, but it's negative in quadrants 2 and 3. All right, so Quinn, Krisanian, Hussein, let me just give you a thumbs up on that. Absolutely correct. So now we have to figure out, right? What is that angle in quadrant 2 and what is that angle in quadrant 3? Because no, we're not talking about x prime anymore. We're actually talking what x is actually equal to, right? X is not equal to 1.23. It's 1.23 away from the x-axis in, as Quinn said, and as Krisania and Hussein are saying, in quadrants 2 and 3. That's where the 1.23 is, in quadrants 2 and 3. So I put my angle in the second quadrant and in the third quadrant, 1.2 or 3 away from the x-axis. That's how I do it. So the question now becomes, what is that second quadrant angle? How do I get that second quadrant angle? You've been doing this all along, right? You did it for the special angles. You can do it for this as well. So how do I get that value of x? This is going to be a decimal answer. By the way, I should put this as being approximately equal to, right? How should I get that answer? It's going to be pi. Well, that's for the third quadrant. I agree. But how about the second quadrant? Let's get to that first. How do I get the second quadrant answer? So Krisania is right. It's pi minus 1.23. That's correct. But before that, Krisania was right about the third quadrant. It would be pi plus 1.23. So the one in the second quadrant will be pi minus, the one in the third quadrant will be pi plus, right? Where pi going back and pi going further forward. So those answers will be approximate answers for this question. So Alexander is saying 1.91. I have no way of knowing that, so I'm going to take that at his word, 1.91. And he's also saying 4.37. I'm going to say that sounds about right. I don't know, but I'm going to go with it. 4.37. Okay. Now, those are approximate answers. Those are approximate answers. But under the conditions where I don't have any special angles, that's all I got. That's all I got. Okay, now let's go back before the class is done and let's see who that is now. Yes, Quinn, please go ahead. Okay, what we're finding, and okay, so you're asking, you want to know what we're actually finding, right? And what we're finding is where is cosine negative? And you answered, I think you answered, it was in quadrants 2 and 3. And what is the deviation that we're looking for? What I call a deviation. The deviation is the cosine to the minus 1 of that 1/3. That's what I call a deviation. Because that deviation tells me how far I am from the x-axis, and then I look to see whether it's positive or negative to know what quadrant to put that deviation in. So we got a deviation of 1.23. That's what cosine to the minus 1 of 1/3 is, positive 1/3. But then we know that we wanted it to be negative 1/3, so we said, okay, put that 1.23 in quadrants 2 and 3. Right? Because that answer of cosine to the minus 1 of 1/3 is just how far am I from the x-axis. It hasn't answered the question of how far. It's answered the question of how far I'm from the x-axis, but it doesn't tell me what quadrant I'm in until I look at the sign of the line before that. The sign of the line before that was negative, so that's where I go with it. So whenever you don't have special angles, you leave it in decimals. Yes, Hussein, let me repeat the question you asked. If you don't have special angles, then you don't have a choice. You have to leave it in decimals, right? And we didn't have decimals in this one, so we didn't have special angles in this one, so we had to leave it in decimals. So 1.91 and 4.37 so far is what we've got. Let's go back and finish the question, though. Cosine of x plus 2 is equal to 0. Okay. So we know how this works. We're going to say that cosine of x equals minus 2. Right? That's the first part of that. And then we're going to say that x is equal to cosine to the minus 1 of, and I'm going to say x prime so far. Let's say 2. Let's not say minus 2 for now. So can you tell me what that angle is on your calculator? Cosine to the minus 1 of 2. Anybody? What is that? You can grab your calculators and tell me what you're getting. What? Something is wrong with Sinduja and Donna's calculator, right? Because they're getting an error on the what? Not what's happening? What's going on? Why is this? What's going on? Well, why are these calculators all blowing up at the same time? What's going on, folks? Davina says no solution, malfunction. That's right. Everything is just breaking down. Here's the answer. There is no solution, right? Does anybody know why there is no solution? That's the question. So no, nobody's calculator is sort of catching on fire or anything. What's going on? Why is there no answer? Why is there no solution? Does anybody know? In the 4 minutes that we have left, why is the calculator incapable of finding the cosine to the -1 of 2? Right? What is the problem? Why is the calculator behaving so badly? What's the problem? Does anybody know? Well, let me remind you of what a cosine function looks like. Right? Let me make a little space here for a cosine function. Right? Cosine function looks something like that. So this goes up to 1. This goes down to -1. So what do you think is the problem? This is a cosine function, but look how far up the cosine function goes and how far down the cosine function goes. Does anybody notice anything? It doesn't exceed 1. It never reaches 2. Thank you, Brandon. Thank you, Brennan. Same thing for the sine function. If I were to draw a sine function, and I can just draw one very quickly, it's the same thing. It goes up to 1, goes down to -1. It never goes above it. So it means that if you get a cosine or a sine function set equal to something bigger than 1, you abandon the ship right there. You're going overboard because that's not going anywhere, right? That's a non-starter. There is no solution for that. How about tan? Does that work for tan as well? Can I get a tan for something which is more than 1? Is that possible? And Brendan is right. You can. So for tan, and I remind you what a tan function looks like. It's not going to be the classiest, but the tan function looks something like this. We did do this on the first, it has some vertical asymptote. Okay, that's not great. But anyway, it goes up forever, goes down forever. I'm embarrassed with that tan function. I'm going to go away from that page. That's a terrible looking tan function. But you get my point, right? It goes up forever, goes down forever. All right. Sine function and cosine function, though, those guys have a limit. There is an absolute range which stops at 1 down to -1, and that's it. It doesn't go any further. So for sine and cosine, if your question is suggesting that your sine or cosine is anything more than 1 or less than 1, then you abandon ship. Okay. However, we do have some answers. Let me go back to the question again. These answers that we got are totally legit. All right. These answers here for X are legit. But those are the only answers that you're going to get in between 0 and 2 pi. All right. I'm going to shut that down for now for today. You do have some homework questions. I can't remember if this issue of no solution comes up in homework or not. I don't remember. But you have some with the squared in it, and you have some with just like the ones we did at first. I have to do a few more of the solutions for trig functions tomorrow, right? So we're not quite done yet, but what we've done so far is sufficient for you to get your homework done. And if you haven't realized it yet, since we came back from the break, I haven't asked you for a homework check yet. So it means that I'm getting very itchy right now in my homework check finger. It's very itchy and it needs, and I probably am going to have to address that. So it does mean that you're due for a homework check. Yes. Yes, Donna, please go ahead. I didn't know because I did include the negative because I went to quadrants 2 and 3. Remember when I asked what quadrant to make cosine negative? It said go to quadrant 2 and quadrant 3. So that's where the negative comes in for cosine. No, it's not. Yes, it's not. It's not. No, no. The answer is 1.23. And what you're looking for is how far you are from the x-axis in the quadrants that matter. Okay? When you're looking for the quadrants. That's correct. That's correct. Okay, you're welcome.